things, and they don't have to, but most of the time your graphs are going to go opposite directions. Because it's this one or this one. And so we saw when we graphed them, we usually have less than something and greater than something. So they went opposite directions. When we have ands, the graphs are going to overlap. Or it's just saying one of them has to be true, and is saying they both have to be true. So what we're going to do is look at what numbers make both things true. So we are looking for an overlap here. For instance, if I said x is greater than or equal to -6 and x is less than or equal to 1. Okay, yesterday we were doing ORs and we just graphed both of those things. So let's start out just drawing those graphs. So the first one, less than or equal to 6. Would it be open or closed? Closed. So we would have a closed circle at -6. Sorry, greater than goes to the right. Second one, and x is less than or equal to 1. So that would be a closed circle at 1 going to the left. And says we need the overlap. So where did both of those things shade? Final click.
Between 1 and -6.
This part right here had both of them. So my actual answer is just from -6 to +1. Now there are different options for how to show me your answer on these. If some people might get to the point where they know and they are only drawing part of the graph, that's fine. If you do both individual ones, then I ask that you do what I did right here and draw in the actual answer above it so I can tell, or highlight it if you like to use highlighters or color pens, something, so I can tell this is the actual answer. Only the numbers between -6 and 1 make both of those things true. Because the solutions fall in between two endpoints, we usually write them differently. When I saw, okay, this is what we start with. X is less than or equal to -6 and x less than or equal to 1. Okay, it really was just giving me the numbers between -6 and 1. So another way we might see that written is -6 less than or equal to x less than or equal to 1. And we put it together in between one big inequality. The smaller number is on the left, bigger number is on the right. Notice both of my inequalities are going the same way. It's saying x is bigger than -6, but it is smaller than 1. Okay, so if we have them just written like that, we can solve it from this big inequality, and we don't have to graph multiple things at the end. If I were going to solve this, we're looking at this center part, and I want to get the x by itself. So if you want x by itself, we would have to do what with this 4? Subtract 4. In an equation, you do it to both sides. Because we really have 3 pieces here, you're going to do it to all 3. So I am subtracting 4 from the left, the right, and the middle. So then 2 minus 4 is -2. Less than or equal to x. Less than 9 minus 4 is 5. So this is my solution. Remember yesterday I talked about you have to give me the solution and the graph. This is my solution, my one big inequality. My -2 had an equal to, so that is a closed circle at -2. 5 did not, so that is an open circle at 5. This tells me x is bigger than -2 but smaller than 5. It's just the things in between them. A couple of you are still missing the difference between the open and the closed. Open is when there is not an equal to. Closed is when we have got the line underneath it, close circle. If it doesn't, open circle. Let's look at number 7. So if I'm trying to solve this, first we have to get the x by itself. Okay, we're starting in the center. To do that, I have to add 13. If you do it in the middle, you have to add 13 to both sides as well. So negative 27 plus 13 is negative 14. Less than 7x, less than 21. So we added to both ends. All right, then what do we have to do to get x by itself?
Divide 7 on both ends.
So if I divide 7 in the middle, we do it on both ends as well. So negative 14 divided by 7 is negative 2, is less than x, is less than 3. Now I have my answer because it is just x in the middle. You have to keep going until you have just a plain x there. Negative 2 does not have the line underneath, so that is an open circle at negative 2. 3 doesn't have a line underneath, so open circle at 3. X is between them. It's bigger than the negative 2 and smaller than the 3. So it looks like this. So ors were the opposite ends. They were going opposite directions. And is going to be in between two numbers. I want you guys to try number 8. So if you're trying to get the x by itself, what did you do first? We do it in the middle, we do it to both ends. So we get negative 12 less than or equal to 3x less than or equal to 6. And then it's x times 3, so we have to divide everything by 3. So we get negative 4 less than or equal to x less than or equal to 2. So your graph equal to means closed circle at negative 4. We also have a closed circle at 2. X is between them, so it's bigger than the negative 4 and smaller than the 2. Number 9. What would I have to do first on this one?
Subtract 1.
So subtract 1 from all pieces. Negative 1 minus 1 is negative 2. Less than 2/3 x. Less than or equal to 4. Now what? So you can either divide by 2/3 or multiply by the reciprocal 3/2. But if we do it to the middle, we do it to both ends as well. So everything gets multiplied by 3/2. So negative 2 times 3/2. Less than, here those cancel, we just get x. Less than or equal to 4 times 3/2.
6.
All right, so negative 3, is that open or closed? And 6 is, and x is between them. It's bigger than negative 3 and smaller than 6. All right, you guys try number 10. So pretty much everyone, most of you divided by 2 first. Could you have also distributed your 2? Yeah, either way. I saw quite a few people that just started with the dividing, so I'll do that. Negative 2 divided by 2 is negative 1. Less than, those 2's cancel, so just x minus 6. Less than or equal to 2. So then we add 6 to 5 is less than x is less than or equal to 8. So 5 was not equal to, that's open. 8 is equal to, so that's closed, and it's just in between. We're doing pretty well with these. I do want to add a problem into this margin here, because there's going to be a couple in the homework like this, and I want to make sure you guys can handle these. If I said x minus 2 is less than 8, and x divided by 3 is greater than 1. Okay, this is an and, but it's written like yesterday's problems. So we have to go ahead and solve both of these separately. So we get x is less than 10. Over here we can multiply by 3. We get x is greater than 3. Okay. An and says I have to find the overlap. So everybody pay close attention here. Less than 10 would be an open circle at 10 going to the left. Greater than 3 is an open circle at 3 going to the right. Where do they both get shaded? My overlap is between 3 and 10. So my actual answer is everything between 3 and 10. Most of the time the problems are written as one big inequality, but they don't have to be. If they're written as two separate ones and it's an and statement, at the end you have to look at the number line and you are looking for what part works for both of them. And it should still be in between two numbers. So this one, it was bigger than the 3 but smaller than the 10. So it was the numbers in between the 3 and 10. Is that okay with everyone? Do we need another example like this? Okay, so just like what we did yesterday, we have a lot of time. I'm giving you the handout. As you turn them in, I'm checking them. If you're making a lot of mistakes, I'm going to be giving it back to you.